So we're starting on section 10.1, page 682. We're going to talk about probability. All right. So on probability, actually probability is the chapter, not really the section. Sorry about that. What we're going to talk about today specifically is counting. Actually, we're just going to talk about the counting principle today. So we need to talk about how to count before we can talk about doing probability. Because when we get to doing probability, probability is the number of possible successes out of the number of possible outcomes. The problem is if you don't know how to count how many are successes and how many total outcomes there are, you can't do probability. So we have to first talk about how to count. And no, I don't mean with your fingers and toes. That's not going to work too well here. So the first thing that we're going to do is we're going to talk about counting using something called a tree diagram. And let's say you are going to the kitchen, you're hungry, and there's not a whole lot in there, and you decide you're going to make yourself a sandwich. And you notice that there are two different kinds of breads. So let's say white and wheat. And let's say there are three different kinds of meat. So you can have turkey, you could have ham, and roast beef. And let's say there are two different kinds of condiments. All right, guys, mustard and mayo. The question is, how many different, if you're just going to choose one of each category, you're not going to mix things, you're going to choose one from each category, how many different kinds of sandwiches can you possibly make? And we need to understand how to go about systematically counting these so that we get an accurate answer as to how many possibilities there are, because that's a crucial step in finding probability, is knowing how many total possibilities there are. So, first thing we have to choose is we have to choose a bread. So we can either choose white or we can choose wheat. For each of those bread choices, we have three different possible meat choices. We either have white with turkey, or we have white with ham, or we have white with roast beef. We could have wheat with turkey, wheat with ham, wheat with roast beef. So far, how many different possible sandwiches are there? 6, right? So the ends of each of these trees gives you a possible outcome. You could have white turkey, white ham, white roast beef. Wheat turkey, wheat with ham, wheat with roast beef. Now we have two different kinds of condiments. So we have mustard. I'll use little m for mustard, and I'll use big M for mayo. How about that? Right? Mustard, mayo. Mustard, mayo. Mustard, mayo. You guys get the idea? This is what is called a tree diagram. And the final ends of all the branches, when you count them up, tells you how many different possible outcomes there are. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible sandwiches. Now again, that's 12 possible sandwiches if we only choose one from each category, right? Now, if we allow you to have both mustard and mayo, okay, now that gives us more possibilities. But keeping things simple for the purposes of our tree diagram, does everybody see how we did this? Now, the problem with a tree diagram, it's very, very good because it gives us a systematic way of counting something. And that's the key. You've got to have a system for counting. Because if you just start writing down the possible sandwiches, what are you inevitably going to do? Yeah, you're either going to repeat something or you're going to miss something, exactly. Okay? And so that's a problem. So we need a systematic way to make sure we don't double count anything, and we need a systematic way to make sure that we don't forget to count anything. And this is one way to organize it so that you can do that. The problem is, what happens if you don't have 2 kinds of bread? What happens if you have 12 kinds of bread? And what happens if you have 13 kinds of meat and you have 8 kinds of condiments? Now all of a sudden your tree diagram spins out of control, right? This thing would take you forever to try and draw it out. But it turns out that from the tree diagram we can see that there's actually a rule that governs what we're doing. Does anybody see how we can get to this answer quickly and easily without drawing this? Just multiply them. And that's what the counting principle says, is that if you have distinct different categories and you're going to make one choice from each category, what you can do is you can take the number of breads, the number of meats, number of condiments, 2 breads, 3 meats, 2 condiments, and multiply those together to get the total number of choices. That's the counting principle. And so now if we had 12 and 13 and 8, now that would just be 12 times 13 times 8, and we can get that answer very easily. Does everybody see how that works? This works for a lot of different situations. One of the situations that this works very nicely for is when we're dealing with things like license plates. And so, back in the old days, before any of you guys were born pretty much, license plates consisted of 6 letters or numbers. Okay? And I believe the first 3 were numbers and the last 3 were letters. I could be wrong on that, but it doesn't really matter. We're going to do it this way for purposes of this example. So, each of the first 3 spaces was occupied by a number, a single digit, 0 through 9. And then each of the last 3 places was occupied with a single letter, A through Z. And you could have repetition and things like that. That wasn't a problem. So the question is, how many total license plates were possible with this arrangement? Well, how many choices are there for the first number? 10. 0 through 9, right? Remember, 0 is a digit as well. So you have 10 different digits. What about the second space? 10, because we could use the same number again. That's not a problem. And the third space? What about for the first letter? 26. And the next one? And the next one? And so what we then do is we multiply all these together to get the total answer for how many license plates were possible. And so you have 10 times 10 times 10 times 26 times 26 times 26. And so that gave you a total of 17,576,000. Okay? That's nothing, guys. That's not very many when you consider how many people own multiple vehicles in their family. Okay? And also when you consider that a lot of times, cars get junked or destroyed or whatever, and it takes a long time for license plates to free back up and go back into the system. Okay? And so once these 17.5 million or so are gone, then what do you do from there? Well, yeah, then what you can do is you can start switching some things around. So to gain more license plates, what you could do is you could put the letters in the front and the digits in the back. So I'll use L and D for letters and digits. That would give you another 17.5 million, but that's still only 35 million, guys. That's not very many. Okay? So then what do you have to do from there? Yeah, you're going to have to add additional digit. And what are license plates like now? License plates now have a digit in the front and then 6 more after that. Okay? 3 letters and 3 numbers. Or because of personalized license plates, you can also have all letters or all numbers or things like that. So that gets thrown into the mix as well. Okay? So you guys see how this is how we can increase them. And originally, when California first started running out, what did they do? The only digit you could have was a 1 in the front. But notice that gave us another 1 times 10 times 10 times 10 times 26 times 26 times 26. That's another 17.5 million license plates. Then they came along and said, okay, well now you could have either a 1 or a 2. So now, by going from a 1 to a 2, we added another 17.5 million. And then they said, okay, well now we'll start doing 3s. Okay, and at one time, the digit in the front actually meant something. For example, like the 4s were only for trucks that were used for work purposes, delivery trucks and things like that. Started with 4s, you know, commercial trucks. But now I think we're all the way up to what, like 7 or something? I think I've seen 7s in the front. So every time they start to run low, then they just add another digit. Now, when they run out of digits in the front, what can they do? They could put a letter in the front, that's 7th place, but in the front as well, in that first location. Or they can start adding an extra digit at the end or an extra letter at the end, okay? And then after all that's exhausted, they could start mixing up how the numbers and letters are, or they could go to an 8th spot on the license plate. So does everybody understand how that works? So this is something that logistically states have to deal with. Now, here's my question for you. What happens if we have that configuration with digits and then letters, 3 and 3, but now you're not allowed to have any repetition? In other words, once you've used a number, you can't use it again. So how many choices would there be for the first digit? 10. Now that you've used one, how many choices are there for the next digit? 9. And then 8. How many letters for the first spot? And then, you guys are so good. When you punch this into your calculator, you're going to get a considerably smaller number. 10 times 9 times 8 times 26. Now, look guys, we've lost about 6.3 million license plates by doing that. We've gone from over 17.5 million to less than 11.25 million. Okay, so these are some of the problems that they're going to give you where they're going to describe a particular configuration of a license plate and ask you how many different possible license plates there are. Okay? All right, any questions about that idea? So you just have to read them very carefully. That's something that's going to be one of the biggest challenges for some of you guys in this chapter, is you've got to read the situations carefully. You've got to understand what they're really describing to you, especially when we get to probability. That's part of what makes probability so complicated, is there are different ways that you can read something, and you have to read it over and over until you get the idea, the gist of what they're really asking you to find. Okay, you don't want to just read it once and say, oh, I know what they're asking for. No, you got to read it a couple of times. Let it really soak in for a minute so that you see, oh, wait a minute, they want me to do it this way. And then you go about doing the problem. Okay? And it's one of the things that drives me nuts about probability questions in textbooks is sometimes they're a little bit ambiguous, and that ambiguity could lead to drastically different answers. Okay, so be very careful about reading these things. All right, any questions about that? All right. The next thing I want to talk to you guys about is I want to talk to you guys about a symbol. Some of you may have seen it before, others of you may not have seen it before, and that is this symbol in math. How do you read that number? 7. Now that would be more like this. 7. That distinctly had an emotion attached to it, right? No, it's more like 7. All right. Anybody know what that symbol is? Well, but what it means, how we read it. The exclamation point in mathematics stands for something called factorial. You can only have factorials with whole numbers. They need to be positive numbers. Okay? And what 7 factorial is equal to, what it means is 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what 7 factorial means. It means you start with that number and you multiply by each integer decreasing by 1 each time until you get down to 1. So you end with 1. Everybody understand that? So 4 factorial would just be 4 times 3 times 2 times 1. Okay? Everybody got that? So that's what factorial means. Now, we're not going to actually see what it's used for. We're just going to actually do some problems with it tonight. But let me talk about where it is on your calculator, because most of you have a factorial button somewhere in your calculator. So pull your calculator out. Okay. On my particular calculator and a lot of the Texas Instruments calculators, where you're going to find factorial is there's going to be a math menu. And on my calculator, above my multiplication button, you see where it says math? So I hit second function and then the division button. I believe this is where mine is. Nope, I take that back. Sorry, guys. Where is it on this one? Yeah, yours will be on, a lot of them will be on PRB. Let me find it on here though, guys. Sorry about that. Oh, I hit the wrong button, that's why. There we go. It was second function. I hit division instead of times. No wonder I couldn't find it there. Now, notice, guys, I have something here that indicates probability. So if I hit my F2 button, now it gives me a new menu, and there's my exclamation point. So if I want 7 factorial, I punch in 7, and then the factorial button, which gives me my exclamation point, and then I hit equals, and it turns out that 7 factorial is really equal to 5,040. 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, a lot of you are going to have a button that says PRB on it, which is your probability menu. If you guys hit the PRB button, then by using your left and right arrow keys, you'll see things like factorial, the exclamation point. You're also going to see things like NPR and NCR. We're going to talk about NPR tomorrow. We'll talk about NCR the day after that. Okay? Is there anybody that has not been able to find their factorial? Okay, let me see your calculator. So on this particular one, let me pause this for a moment. Now, what you're going to be doing is you're going to be asked to find things, for example, like maybe they'll give you a problem that looks like this. And they want you to punch that into your calculator. The way you punch this into your calculator, you do have to be careful and think about it for a moment. This is going to be 12 factorial divided by, if I do 12 minus 7 factorial, oops, sorry. Seven factorial, is it going to give me what I want? No. What's it going to do? Yeah, it's going to do the factorials first, then it's going to do the division, then it's going to do the subtraction. So what you need to do is one of two things. You either need to do parentheses, 12 minus 7 close parentheses factorial, and get your answer. Or you could just do 12 factorial divided by what? 5 factorial. Either way, this is the answer that you get. Now, let me show you how to do this manually, guys, because if you're ever taking a test like the CSTs or something where you're not allowed to use a calculator and you have to simplify these things, or you're allowed a 4-function calculator but not one with factorial on it, how do you do this kind of problem? Well, what you do is you work out the bottom. The bottom is 5 factorial, so you have this. And now what you do is you start to break down the bigger number until it matches the smaller number. This is really 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5. And then you leave the rest of it as a factorial. What's the purpose of doing that? What can I do now? You can cancel out the factorials, the 5 times 4 times 3 times 2 times 1, and then you can just multiply those things together on a regular calculator by hand if it's not too many numbers. So does everybody understand how that works? So you break down the bigger one until it matches the smaller one, and then you can cross those guys out and then go from there. But for purposes of the homework, you can just do it on your calculator. Okay? All right, any questions about that? Now, what if you were doing something like 12 factorial divided by 12 minus 7 factorial times 7 factorial? Well, what I would do is I would do it like this. But when I put it in my calculator, where am I going to have to make sure I put parentheses? Around the denominator, right? So I'm going to have to do it as 12 factorial divided by parentheses 5 factorial 7 factorial. Now it'll give me the right answer. But if I don't use those parentheses, it's going to do the division first and then take the answer and multiply it by 7 factorial. Let me show you. 12 factorial divided by 5 factorial, 7 factorial. Drastically different answer, isn't it? Because it didn't divide by that 7 factorial, it multiplied by it instead. So you've got to be aware of where you need parentheses when you punch things into your calculator. Now, another way you can do it if you don't like using the parentheses on your calculator, you could do 12 factorial divided by 5 factorial, get the answer, and then divide the answer by the 7 factorial that's still on the bottom. And that will get you the right answer as well. There's a couple different ways you can do that. Any questions about that? Okay, I think that's all we're going to really work with today. Let me double check that. Yeah. So let me give you guys the homework assignment.